G'day lads, in this video I'll build a spreadsheet to generate live and pre-game probabilities for the money line, spread and total points markets for an NCAA basketball game. If you would like to download this spreadsheet, then you can click the first link in the description below to go to the Excel Lads Patreon. Here I've also connected an API so that a user can compare the spreadsheet's probabilities to those offered by the bookmaker for any upcoming game. Enjoy the video lads, and if you find anything useful, please subscribe. To start lads, open a blank spreadsheet and name it raw data. In here, we're going to import all the data we need for the model using Power Query. This will come from two websites, College Football Reference and teamrankings.com, and I'll put all the necessary links and what columns they should be imported into the description below. I've skipped this step in the video, the process of actually importing the data from the web using Power Query, as that process is unique for every user depending on the version of Excel you're using as well as the computer you're using. So in column A, we'll start with the basic stats for each team from collegefootballreference.com from the previous season, and then in column AO, the stats for the current season. From column CC, the opponent stats table for last season, and then in DQ, the opponent stats for the current season. That's the stats for the teams each school has played. And then from columns FE to FI, the teamrankings.com upcoming games. So that's the schedule for the day's play brought in from teamrankings.com. Using all this data, we've got to sort it now so that we can make ratings from it and measure the strength and calculate the ability of each school on offense and defense. So create a new worksheet called NCAA Team Stats, and then I'm going to do some formatting here. So from columns A across, type in the text schools, 2 points, 3 points, free throw for, 2 points, 3 points, free throws against, SOS standing for strength of schedule and games. Copy and paste this into columns J through to Q, and that'll be for the last season and current season respectively. Now from columns R through to X, include the 2 points, 3 points, free throws for and against, as well as games in the column beside it. And then from column AF to AK, make 2 point, 3 point, free throw, attack and defense ratings. These will be our final ratings for each school. From AN2 to AN3, define the home advantage and games threshold as 2.5% and 15 respectively. And below that, from AN5 to AN7, we're later going to calculate the average 2 point, 3 point and free throws made per game. I'll format the table to the left with some color. And then after I do that, I can find the unique list of schools for the data set. To do this, I'll use the unique function so that we can spill an array of the list of unique schools in the college football reference data set within the raw data worksheet. So in cell A3, it's going to be equals unique raw data B1 to B1000, which is the end or more than the end of the data set. So it's capturing every possible school to be listed there. I'll press enter, but you'll see the top two values, because the unique function picks up every bit of unique text, 0 and school, but we want to remove that, and I'll do this using the drop function. So drop, open bracket, our array is the original unique function, and we're taking the top two rows off that list. Once I press enter, it'll return the complete list of college football teams that we are now going to find the 2 points, 3 points, free throws for and against for the previous and current season, as well as the SOS adjustment and number of games they've played. So beginning in I3, I'm going to find the number of games each school has played in the previous season. To do this, I'll use an XLOOKUP function wrapped in two if-error functions. My lookup value will be the list of teams in the A3 array to the left. The lookup array is the list of teams in the previous season's basic stats for data set. So that'll be from AP1 to AP1000, as column AP is the column with the list of schools in it. And the return array will be the number of games they've played immediately to the right in column AQ. So that range is AQ1 to AQ1000. Make sure to absolute reference that by putting a $ in front of both the column and row. Close the bracket, comma. If there's an error there, because sometimes schools have an NCAA text after them in the previous season version of the college football reference data set, I'm going to paste this XLOOKUP function and change the lookup value to the A3 array and the text in speech marks, space NCAA, speech mark. So that just adds NCAA to each team so that if there's an error, the correct team is returned. So I'll close two brackets there. If there's still an error, just return 0 games, meaning the school was not seen at all in the previous season. And then I get an array of all the games each team has played in the previous season. Next, I'll return the SOS, strength of schedule rating, for each team in the column immediately to the left in column H. So I'll just copy the formula from I3 across to H3, and I'll change AQ to AV in both XLOOKUP functions. And then I can press enter on that, and the SOS will appear for each team. A negative value meaning they've played teams of lesser quality, a positive value meaning the opposite. So I'll copy that formula into cell C3 now, the 3 points 4, and I'll add another if error function at the beginning of the XLOOKUP function. At the end of the formula, I'm going to divide by $I3 the games each team has played and that array. I'll add a comma and a 0, close the bracket, and I'll also change the return array columns from AV to BN on both occasions, because column BN is where the number of 3-pointers they have made lies. So I've got that for each team now. I can reduce that to 1 decimal place. And I can do the same thing for free throws. I'll copy the formula across to cell D3. And then here, all I've got to do is change the return array for the two XLOOKUP functions to the column where the free throws lie for each team. And in this case, that's column BQ. Once I press enter on that, the free throws per game 4 will populate the spreadsheet for each school. And now I can copy and paste the formulas from C3 to D3 into columns F and G to find the number of 3-pointers and free throws conceded per game by each school, as well as the change in the return array. I'll have to change the lookup array from AP to DR so that I'm getting the opposition data set, and I'll do that for both XLOOKUP functions. The return array here is column EP for the 3 points against. AP goes to DR again, and BQ goes to ES, so we're returning the free throws conceded by each school per game. Press enter on that. So the reason I didn't do the 2-pointers for and against columns to begin with is because there's actually not a dedicated column to them in the college football reference dataset. Instead, we have a field goals made column and a 3-pointers made column. So to find the 2-pointers for, I can simply subtract the 3-pointers for from 3-pointers for, and then change that first 3-pointer XLOOKUP function to a return array of BK, which matches the field goals made. So 2-pointers are equal to field goals made minus 3 points made. So that's what we're doing here. So just copy the XLOOKUP function, add a subtraction sign to the end of it, and paste it again. And here I'll change column BN to BK just as I did above. Press enter on that, and then you will spill the 2-pointers made per game for each school. And I can use the exact same process to find the 2-pointers conceded by each school per game by copying across the formula from cell F3. Again, I'm going to copy the original XLOOKUP function to grab the 3-pointers made, add a subtraction sign to the end of it, paste it, and then change the first XLOOKUP function at the beginning of the equation to the field goals made column, which is column EM here. I'll do the same thing for the second XLOOKUP function. After the first equation, minus sign, paste the original equation, and then change EP to EM at the beginning. Once you do that, press enter. And now we've got our stats compiled for the previous season. We need to do the same thing for the current season, in this case 2025 to 26. These formulas are likely to be shorter in length because we don't need an if error function. All the schools listed in the A3 array will appear and have stats for the current season. So we can go right ahead and begin in cell Q3 with an XLOOKUP function. We're looking up every school in the A3 array, and we're looking that up in the array B1 to B1000 and returning the range C1 to C1000, the number of games they've played in the current season. I'm going to absolute reference the lookup and return array by putting a $sign in front of both the row and column before I press enter, and that spills the list of games each school has played in the current season. I'll copy that and paste it into the cell immediately to the left of it in column P, and the return array to return the strength of schedule ratings college football reference has granted each school so far in the season is located in column H within the raw data worksheet. I'll paste it again in K3, and we can grab the 3 pointers in column Z. Before I press enter though, I've got to divide by the number of games each school has played so far in the season. So divide by $sign Q3 hash, which will fix the column games so that when I drag the formula to the right and change the return array to AC, this will pick up the free throws for and still divide by the number of games each team has played in column Q. I'll copy and paste K3 into N3 now and change the lookup array from column B to CD, again getting the conceded stats from the opponent, and the return array will become column DB to return 3 pointers against. And going into column O, I'll drag that formula across and change the return array from DB to DE. Now I can come up with the formulas for the 2 pointers for and against. And to do that, of course, the formula is the field goals made minus the 3 pointers for. So it's just a task of copy and pasting the original XLOOKUP from the 3 pointers for minus itself, and then changing the first part of the equation with a return array to the field goals made. So minus and paste. And then column Z will be changed. We'll change that to column W. And make sure to put a bracket around both XLOOKUP functions so that the figure being divided by the number of games being played is the 2 pointers for rather than the 3 pointers for. Reduce that to 1 decimal place, and then I'm going to copy that over to cell M3 and change the ranges so that it's correct for the 2 pointers conceded by each team. So the lookup array becomes CD, return array CY, CD, and then Z becomes DB. Press enter. And now we've got our raw stats for every team in the current and previous year. Now I'm going to adjust these raw stats for the SOS adjustment seen in column P for the current year, as well as the adjustment for the previous year, so that teams who have had a tough schedule will have their points conceded reduced, as well as their points scored increased if they've faced a tougher defense. So to do this in R3, if error, 2 open brackets, the B3 array divided by open bracket, the B3 array plus the C3 array plus the D3 array. Make sure to absolute reference those ranges by putting a $sign in front of both the column and row. Close bracket multiplied by $sign H $sign 3 hash. multiply that by half, and then divide by 2, as this is the 2 points for column. Close the bracket, plus the B3 array, comma, 0, close the bracket. When I press enter on this will give me the adjusted values. Abilene Christian has their 2 pointers 4 reduced from 21.0 to 20.7 because their SOS is negative, meaning they've faced an easier schedule than the average team, reducing their 2 pointers 4. I'll drag this formula across from R3 to T3, and the only change I'll make is deleting the divided by 2 in T3 and changing the divide by 2 to divide by 3 in S3 so that it's appropriately calculating the adjustment for 3 pointers when dividing by 3 and free throws when dividing by 1, or keeping the equation the same. Now I'll write the same formula for the against stats. In U3, begin with an if error function. 2 opening brackets, our value is the E3 array divided by, all in brackets, the E3 array plus the F3 array plus the G3 array. And if I scroll across, that's the 2 points against divided by the sum of the 2 pointers, 3 pointers, and free throws conceded. Close the bracket, multiply this by negative $H3 hash, which is the H3 array, the SOS adjustment for the previous season, multiply by 0.5 divided by 2, close the bracket, plus E3 hash, the E3 array, comma, 0, close the bracket, press enter, and then I'm going to drag this across to column W, again making those 2 changes, divided by 3 in column V and divided by 1, or deleting the divided by 2 in column W. And for the games column, I just need to list the games a team has played in the current season, and so that's just array I3, which we've already calculated. I've got to do the exact same thing from column Y to AE to the right. I just need to change the ranges. So I'm going to copy and paste the formula from R3 into Y3, and the formula will now become if error, 2 opening brackets, J3 divided by J3 plus K3 plus L3 multiplied by the P3 array times 0.5 divided by 2 plus the J3 array, comma, 0, close bracket. Once you've got that, drag it across to the AA column and change it so that it's divided by 3 and divided by 1 as we did before for the 3 points for and free throws for formulas. Now for column AB, the formula will be if error, opening bracket, M3 divided by the M3 plus N3 plus O3 array, multiplied by negative P3 times 0.5 times 2, closing bracket, plus the N3 array, comma, 0, close the bracket, drag it across to AD, and then make those adjustments like we did before. And of course, the AE column will just be the number of games played in the current season, which is equal to Q3 hash, the Q3 array. Now that we've got the adjusted number of 2 pointers, 3 pointers, and free throws scored and conceded for each team, taking into account the strength of their schedule, we can compare them to every other team by making a rating for them. So in AF, you're going to make the formula equals if, opening bracket, $AE3 hash is greater than or equal to $AO, $3, comma, then return the Y3 array divided by the average of the Y3 array. Close the bracket there. If not, the value if false is $AE3 hash. You're going to divide that by $AO, $3, the game's threshold to the right there, and multiply that by Y3 hash, the Y3 array, divided by the average of that array, Y3 hash. Close the bracket. Then you're going to add the remaining portion, which is opening bracket 1 minus opening bracket $AE3 hash divided by the game's threshold to the right, AO3. You're then going to close this bracket twice and then multiply by the R3 hash array and divide that by the average of the R3 array. So essentially what this formula does is it uses the games threshold to determine the weighting from each season. If more than 15 games have been played in the current season, then the attack or defense rating will be solely based on the team stat for the current season. However, say if only 10 games have been played, then 10 divided by 15 is from the current season, whereas the remaining 5 out of 15 percentage of the data will be derived from the team's performance in the previous season. So you can drag the formula in AF3 across to AK3, and that'll fill out for everything and create attack and defense ratings for the 3 methods of scoring. An attack rating of greater than 1 is good. If a team has an attack rating of 1.04, they score 2 pointers 4% more than the average team, whereas if it's less than 1, they score less. Of course, you would like an attack rating to be higher than 1, whereas a defense rating lower than 1. You want to concede less than the league average team, which is always 1. Then you're going to compute averages in cells AO5 to AO7, like I've done to the right here, which will be important for scaling in determining the expected number of 2-pointers, 3-pointers, and free throws scored in a matchup for each team. Now we'll calculate this in the dashboard worksheet, and I'll do a bit of formatting here. The dashboard worksheet will be the center of the entire spreadsheet. It'll be where you can select a home and away team using a list, and that'll project the expected points for each side, and using the expected 2-pointers, 3-pointers, and free throws calculated from the NCAA team stats worksheet we just made, it will come up with probabilities using the simulations we'll make towards the end of the video for the money line, spread, and total points. So it'll also have the ability to put in the time left in the game and the current score, so that live in-game probabilities for the 3 markets can be determined. Select cells E3 and E6, go into the data tab and select data validation. Here we can allow a list, with the source being the list of unique teams in the NCAA team stats worksheet, A3 hash. And when I press OK, this will make a drop-down list where we can select any 2 sides for the game. Cell B6 should be the home team, so you can change that. And we'll select the away team as Delaware State, with Howard being the home team. Now open a new worksheet and name it simulations. In here, we'll run 5,000 simulations of a match between Delaware State and Howard, B1 being the home side and C1 being the B1 being the away side and C1 being the home side. A2, the text trials, and then A3 below spill numbers 1 through to 5,000, representing the 5,000 independent trials we'll make. In G1 and H1, spill the away side and home side again. And then from F2 downwards, put in the text expected 2-pointers, expected 3-pointers, expected free throws, and then live expected 2-pointers, 3-pointers, and free throws, with F9 having the text time left, and then format it like so. So before we can calculate a percentage of the time left in a game, go into cell O3, and then in the data tab again, go into data validation, allow a list with the values 1 or 2, 1, 2. So this will be the period. We can select whether the game's in period 1 or period 2. Then below it in 06 is where we can put the time left in the half. So 20 minutes to start, 10 minutes halfway through, or 0 minutes at the end. So I'll put 20 minutes to begin, with the current score being 0-0. So in period 1, 20 minutes left of that period, current score being 0-0, that's the start of the game. Now, there's a formula to calculate the time left based off of this formatting. Using an if function, our test will be whether the O3 cell in the dashboard worksheet is equal to 1. If that's true, then we'll add 20 with a value function where the text will be text before, open bracket. The text is in cell 06 with a delimiter of the colon. So speech mark, colon, speech mark, close the bracket twice, plus value, the text being text after, open bracket, 06, the delimiter the same, the colon, speech mark, close the bracket twice, and then divide by 60. Now, if that's false, if the time left is in period 2, then the value will be a value function. Inside that, a text before function where the text is 06. The delimiter is the same as before. You're going to close the bracket twice and add another value function where the text is text after, open bracket, dashboard 06, delimiter the same. And then you're going to close the bracket twice and divide by 60 there. Close the bracket. But when I press enter, or before I press enter, I'm going to divide by 40. So close the bracket, divide by 40, and initially I get an error. And that's due to the formatting in the dashboard worksheet. So you can enter it again. There's nothing wrong with the formula here. What you need to do is make sure that cell 06 is formatted as text. If you just do general and you put in 20:00, it thinks it's a time. But we don't want it as a time. We actually want it as text. So make sure text is labeled above in the home bar here, and then the time left will become a percentage, which we want as 100 when we're in period 1 with 20 minutes left. If I change it to the second period with 20 minutes left, it becomes 50%. And if there's 5 minutes left in period 2, then obviously there's 12.5% left in the game. I'll change it back to the start of the game, which is always period 1 in 03 and 20 minutes left in 06. And I'll begin by calculating the expected 2-pointers for Delaware State, the away side, in cell G2. Firstly, I'll look up G1, the name of the away side, within the lookup array of the list of teams within the NCAA team stats worksheet. That's A3. And the return array is the array in AF3 hash, which is the 2-point attack ratings for each side. I'll then multiply this by the 2-point defense rating of the home side, which can be found using an XLOOKUP function where H1, the name of the home side, is the lookup value. Again, we're finding that within the lookup array of A3 in the NCAA team stats worksheet. And this time, instead of returning the attack rating, I'll return the defense rating, which is in AI3 downwards. Close the bracket there. I'll then scale this by the average 2-pointers scored in a game found within cell A05 of the team stats worksheet. I'll put a $sign in front of the AO so that I can drag it downwards and across without that value changing the column. Then I can divide this by the square root of 1 plus the home advantage in AO2. I'll absolute reference that. Close the bracket, press enter. Delaware State are expected to score 16.47 2-pointers against Howard. And I can drag that down to cell G4. And all I'll need to change is the return array. So AF will become AG and AI will become AJ for 3-pointers, and for free throws, AF will become AH and AI will become AK. So press enter on that. And then I can drag these formulas across after reducing them to 2 decimal places. I'll get the same value. There are 2 changes I'll need to make here. First of all, the lookup value has to switch. Instead of looking up the away side's attack rating, I'm looking up the home side's attack rating and then multiplying by the away side's defense rating. So G1 switches with H1 and vice versa. And instead of dividing by the square root of 1 plus the home advantage, because Howard is the home team, I'm multiplying by the square root of 1 plus the home advantage, so that the total advantage is equal to 2.5%, which is what we defined in the NCAA team stats worksheet. Make those changes like I've done there, And the live expected 2, 3, and free throws will be simply equal to G2 times G9, absolute referenced in cell G5. I can then drag this downwards and across so that the expected 2-pointers, 3-pointers, and free throws halve when the time left in the game is halved. So if it's half time, then these values are halved, and that's exactly what we want them to do. So I'll change it back now. And next I'm going to make a huge formula using the let function, which will allow me to simulate a game between the home and away side, Howard and Delaware respectively, using the values to the left there. And I'll do this using the binomial distribution, assuming a team scores 2-pointers, 3-pointers, and free throws at a rate according to the binomial distribution, with values to the right being the mean. So firstly, with the let function, I'm defining NOT, the number of overtime periods, as 3, comma, the away expected 2 points will be G2, the away underscore expected 3 points will be G3, comma, the away expected free throws, comma, will be G4, comma, and then we'll do the same thing for the home side, Howard. The home expected 2 points figure will be located in H2. Again, make sure you absolute reference all these cells by putting a $sign in front of both the column and row so that when we drag down, these references stay constant. The home expected 3 points is in H3 and the home expected free throws is within H4. So now we'll calculate what I'll call reg, and this will produce the regular time score between Delaware State and Howard, not including any overtime that is necessary. So that'll be using the hstack function, where the score will be Q3 plus the binomial inverse function, 10,000 for the number of trials, comma, the probability of success is equal to the away expected points, multiplied by G9, the time left, and then I'm going to divide that by the number of trials, 10,000, with the alpha argument being the rand function, open bracket, close bracket there, close the bracket, and then I'm going to multiply this by 2 as it represents the number of simulated 2-pointers made by the away side, and multiplying by 2 gives the number of points it contributes towards the regular time score. I'm adding another binomial inverse function with, again, 10,000 trials, but this time the probability of success is equal to the away expected 3 points multiplied by G9, the time left, divided by 10,000 with the rand function randomizing it before I multiply by 3 to get the contribution of 3 points. And then the binomial inverse function is going to be used again with 10,000 trials, a probability of success equal to the expected free throws multiplied by the time left divided by the number of trials, 10,000, with alpha being the rand function yet again. So once I close the bracket there, I'm going to use a comma to list the second array in my hstack function, and that's going to be the home side's regular time points, which is equal to the home side's current score, plus the 3 binomial inverse functions we went through earlier. Here, all we have to do really is just replace away with home. So it's still going to be the home expected 2 points multiplied by G9, the time left, and then dividing by 10,000 again. And of course, using the rand function to produce a random value according to the mean defined in the home expected 2 points argument. So multiply by 2 and add the 3 points binomial inverse function. That's equal to a probability of success of the home expected 3 points multiplied by G9 divided by 10,000, multiply by 3 when you're done with that function. And then finally, you're adding the last binomial inverse function, which has 10,000 trials, a probability of success equal to the home expected free throws multiplied by G9 divided by the number of trials in 10,000 with an alpha of the rand function. Close the bracket there, and then close the bracket a final time to finish the hstack function. Our next name will be OT. This will be an array representing the necessary overtime periods required for the game to finish. That is A game can't finish with both teams on an equal number of points, so this will simulate an overtime equivalent to 5 minutes or an eighth of the regular time period, and I'll use the make array function to do that. So I'll start off with not, comma 2. The lambda function will be used, r, comma c, comma an if function. If c equals 1, then use the binomial inverse function with 10,000 trials. Away expected 2 points divided by 80,000, comma rand function times 2. And the 80,000 is used because that's 10,000 divided by 8, as an overtime period is 5 minutes, and there are 8 of those in a full game of 40 minutes. So the second binomial inverse function is the away expected 3 points divided by 80,000 for the probability of success, multiplied by 3, of course, for the contribution of 3 points, and then you're adding another binomial inverse function. Again, 10,000 trials, away expected free throws divided by 80,000, comma, rand function, open bracket, close the bracket again. If c is not equal to 1 in this lambda function, then we're going to produce the number of points contributed by the home team in an overtime period equal to the binomial inverse function, 10,000 trials, home expected 2 points divided by 80,000, comma, rand function, open bracket, close bracket, times 2, that's a 2 points. We'll go through the process again for 3 points. Probability of success equal to home expected 3 points divided by 80,000. Alpha equal to the rand function again, multiply by 3, and then the last binomial inverse function will be representing the contribution from free throws for the home side's overtime points. After dividing by 80,000, use the rand function yet again. After you do that, close the bracket 1, 2, 3, 4 times so we can move on to our next name value. We'll name this full underscore score, and that will be using the vstack function, where the first array is the reg argument and the second is ot, which we defined earlier. Close the bracket there. The next name is ot underscore 1, representative of ot1 or overtime 1. We're using the by-col function. Within that, use the take function so that the array is full score, and we're taking 2 rows. Close the bracket, comma, we're using a lambda function where the argument is col, comma, sum, open bracket, col, close the bracket 3 times. The next name is ot underscore 2, overtime 2. The by-col function, use the take function with the array full underscore score. We're taking 3 rows, close the bracket, comma, use the lambda function again. The parameter is the col, comma, sum, col, close the bracket 3 times again, comma, this time ot underscore 3, comma, by-col, open bracket, take, open bracket, full score, this time take 4 rows, close the bracket, and the same lambda function again, open bracket, col, comma, sum, open bracket, col, 3 closing brackets. Now, comma, if the choose cols function with reg, comma 1 is not equal to, defined by the less than and greater than signs next to each other, choose cols, reg, comma 2, then return reg. If not, we're doing another if function where if choose cols overtime 1, the first column in that is not equal to the second column in overtime 1, then we're going to return overtime 1. If that's not true, then we're going to another overtime period where that's represented by an if function yet again. If the first column in overtime 2 is not equal to the second column in overtime 2, then return overtime 2. If not, then we'll do one more if function, I believe. If, open bracket, choose cols, if the first column in overtime 3 is not equal to the second column in overtime 3, then we can return comma OT underscore 3. If that's false, then we can return OT3 again, close the bracket 5 times, and this is our final formula. So when I press enter on that, Delaware State lose to Howard 41-74. Whenever I press backspace or refresh the worksheet, a new score line is simulated and produced. So that's one example. In another, Delaware wins 69-68. We need to learn the distribution of outcomes so that we can find the probabilities for the 3 markets. And from this, we can also calculate the expected score. So I'm going to drag the formula down to row 5002 so that 5,000 trials are performed, so that we can do some analysis to see the probabilities with regards to the money line, total points, and spread. First though, we can use the expected score formula to find out what should be the average of the simulations. So for the away side, that's equal to G5, the live expected 2 points multiplied by 2, plus a live expected 3 points multiplied by 3, plus the live expected free throws. And then we've got to add Q3, the current away team score, to that. So Delaware State are expected to score 55.5 points against Howard. And I'll do the same thing for the home side Howard, just in column H this time. And you'll find in the simulations that the average points for each team should be roughly 55.5 and 67.72 respectively if we go back into the simulations and find the average of those 5,000 simulations. There'll be some variance every batch of 5,000, but that's what it's centered around, the expected value. So to find the probability of the away side Delaware State winning, we can count the number of simulations in B3 to B5002 that beat its counterpart in the cell next to it within column C, from C3 to C5002. Using the sum product function, I can count all these and then divide by 5,000 to get a probability. So I'll copy and paste that into L6 and change the greater than to less than, so that the total is 1 if there are no draws within the 5,000 simulations, which are unlikely to happen considering we put in place 3 5-minute overtime periods. I'll add in a color scale now within conditional formatting so that the team most likely to win is highlighted in green with the underdog highlighted in red. And you can see that the values in L3 and L6 change slightly every batch of 5,000 simulations whenever they're refreshed due to the nature of simulations and the variance associated with it. If I change it to halftime with Delaware State leading 30-20, then the expected score and win probabilities update, reflecting their 10-point lead at the break and the fact there's only 20 minutes left to play. So now I'm going to do some formatting below so that we can analyze the 3 markets, spread, total points, and money line, and that we also have the ability to select parameters for the spread and total points so that we can see the probability of points going under or over a certain threshold within the game, and also the probability of Delaware State or Howard winning given a certain advantage or disadvantage. So I'll just do this formatting below, and I'll highlight cells we can change with the color green. And I'll begin in D11 and D12, where we'll give Delaware State, the away side, a disadvantage of 3.5 points, and we'll give Howard an advantage of 3.5 points. So in cell E11, I'll use the sum product function where I'm counting how many instances Delaware's score in their column B3 to B5002 plus their spread value in D11 is greater than the home side score in C3 to C5002 for those 5,000 simulations. That is how many times does Delaware cover the spread. And here they cover the spread 52.7% of the time for this batch of 5,000 simulations. I'm going to drag that formula down and change it so that it's C3 plus C5002 plus their spread is greater than the away side. So that'll be for the home side. I'll put the probability to 2 decimal places. And what we want to be able to do is change the cells in D11 and D12 so that the probability updates next to that. And you can see once you put in a new number and press enter, it does so. Now, next, I want to be able to represent the probability with its fair value. So that'll be under odds in F11 to F12. What I'm going to do to the right is create a list made up of American and decimal text in P9. And here we can select whether we want the fair odds to appear as American or decimal. Decimal being, for example, for something with 50% chance of happening, $2, whereas American odds would have that as plus 100. So in the odds cell next to Delaware's probability of covering the spread, we're going to use an if function where if P9, the cell, whether it's American or decimal, is equal to American, then we're returning an if function. If E11 is greater than or equal to 0.5, then we're using the text plus space, speech mark, and round, 3 opening brackets, 1 divided by E11, close the bracket minus 1, close the bracket times 100, and we're rounding with 0 digits, close the bracket, comma, if false, negative sign, space, speech mark, and negative round, open bracket, negative 100, divided by 2 opening brackets, 1 divided by E11, close the bracket, minus 1, close the bracket, rounding to 0 digits, close the bracket twice. If all that's false, just put 1 divided by E11, which is the formula to produce decimal odds. And when I drag that down to F12, we get fair odds based on the 19% and 80% probability, respectively, of plus 424 and minus 424. If I change the current score to the start of the game where it's 0-all and change the spread back so that Delaware has an advantage of 12.5 points and vice versa on the opposite hand for Howard, the probability becomes about 50-50. I can do the same thing for total points, so I can see based on the threshold in K10, 139.5 points using the sum product function with the double negative at the front, open bracket. I'm counting the amount of times that the simulations in B3 to B5002 plus C3 to C5002 exceed the threshold in K10, 139.5 in this case. And then of course, for the amount of instances that does happen, I'll divide by 5,000, the number of trials, to get a probability. And when I press enter, I can drag the same thing down for under, but I'll just have to change the greater than to less than to find the under probability here. So once I've done that, again, the sum should equal to exactly 100%. I can convert to fair odds by copying and pasting the formula in F11 and 12 into M12 and 13. Initially, it'll give you an error though. That's because L12 has to become K12. I've merged that cell, so it's just a different formula there. And then I can do the same thing to find the money line probability, just equal to L3 and L6, and I can copy and paste the odds from M12 into J17. So now I've got the probability for the 3 main betting markets available for every matchup. If I put in a new team for the away side Navy and for the home side American, the expected score will update, so will the probabilities for the 3 markets. I can change them however many times I want. I can update the time left and the current score, and the probabilities will update based on the new simulations performed in the batch of 5,000 we simulated in the simulations worksheet. The cells highlighted in green you can always change to see how the probabilities update below. And to update the spreadsheet every day, you can go into the data tab and press the refresh all icon. This will update the spreadsheet's connection with the internet and bring in the newest up-to-date stats right into the spreadsheet to inform the predictions. Again, lads, if you would like to download this spreadsheet, you can visit the Excel Lads Patreon. That's the first link in the description below, where you can download the spreadsheet and use it every day for every upcoming NCAA basketball game.